Well, good afternoon, everyone, and welcome to today's live astronomy program from the Science Museum of Virginia. My name is Justin, one of the astronomers here at the museum, and I'm happy to be your guide today. If you're just joining me for the first time this week, welcome to the show. We've got a couple dozen videos in the archive for you if you want to catch up, but you don't have to have seen those older episodes to enjoy today's show. I will refer to some topics we've covered before. So if you want to circle back after the show, just head to the video archive. We've got them on YouTube as well. If you've watched some of those previous shows, welcome back. Happy to have you on board again. And of course, happy to have our sponsors with us again as well, Allianz Partners. Thank you for your support. Now, for today's show, we're going to be using software similar to what we use up in the planetarium here at the museum. It's software from Evans and Sutherland called Digistar. We're using Digistar 7 for today's show, and it can do some pretty cool stuff. So I recommend watching the show in full screen if you are able to. If you have questions or comments throughout the show, feel free to leave those in the comments as well. If I'm able to during the show, we'll address those, or maybe you'll be featured in a future edition. All right, with that, I think we can dive into today's show. Today's show has a special theme. Let's see if we can figure it out. I'm going to switch over to our Digistar view here. I've transported you outside. We're checking out the nighttime sky a little bit later on tonight. This is just a few hours from now. Looks like about 10 p.m. this evening. Now, if you go outside tonight, a couple of things you may notice. Just after sunset in the southwest, we've got two planets pretty close together, Jupiter and Saturn. We'll be talking more about them in the coming days here in the museum. We'll probably feature them in this show in a couple of weeks, so stay tuned for that. Then, a little before 10 p.m., the moon will be rising. That's actually on your screen now. You may just be having a little trouble picking it out. Another thing that you may notice in the coming weeks, the next 2 weeks or so, we're in the midst of the Geminid meteor shower. Now, before I go any farther, I need to tell you about a new feature for today's show. Gonna kind of throw it back to my childhood a little bit. We're gonna have a secret word, or I guess a secret phrase for today's show. And let's see what that secret phrase is for today. It's going to be tiny particles. Okay, and what do we do when I say tiny particles? I just want everybody to yell really loud. I won't be able to hear you, but I think it'll be pretty funny. I mean, if someone's in a Zoom meeting or something in the room next door, maybe yell quietly. But yeah, every time I say the phrase tiny particles, it's as easy as that. You just got to make a little bit of noise. Okay, so back to tonight's sky. It's about 10 p.m. tonight. The moon on the screen there, and oh, I just saw a little streak of light at the top of the screen. As I mentioned before, that special segment, we are getting started with the Geminid meteor shower. It starts to ramp up today, actually, but it'll peak in about 10 days. Now, meteor showers, sometimes those are called shooting stars. They aren't stars. A meteor is just something that we see when, some tiny particles, in this case, that broke off the surface of an asteroid named Phaethon, enter our atmosphere and burn up. So you can keep an eye out for those over the next couple of weeks as well. But I really just wanted to focus on the moon to get us started today, because one of the themes of today's show is sample return missions, our attempts to bring pieces of the universe back to the Earth. So let's zoom in on the moon just a little bit. And over the course of this last week, a pretty interesting mission has been there doing some interesting things, working on some sample returns. So let's zoom in on the moon here a little bit. Outside in the real sky, look bigger and brighter than it did on your screen at first. It'll be pretty tough to miss. But there you go. There's the moon as it will appear tonight. Now, at the location of that little red star, you may be able to pick out on your screen, a spacecraft was sampling the surface of the moon, and should be bringing those moon rocks and moon soil back to the Earth in the next week or two. Now, the mission is one I mentioned a couple of weeks ago. It was launched by China. This is their Chang'e 5 mission, their third attempt to land on the moon, and the first attempt to bring material back from the lunar surface in a little over 40 years. Of course, the Apollo astronauts, when they were there, they picked up some moon rocks, brought them home. The then Soviet Union had some robots that landed on the moon in the 1970s. They brought some lunar samples back home as well. But nobody has tried sample return from the moon since then. So if this mission is successful, it'll be an historic achievement. Now, I could let this video keep playing, but I've got some real imagery from the spacecraft now, so I am going to get rid of that, and let's switch to this video from the spacecraft that actually shows their landing. So they launched a couple of weeks ago now, got to the moon, got their orbit just right, and then there are two spacecraft involved, the lander separated from the orbiter, and these are real images from the landing craft. So you're gonna see it descend over the surface of the moon. One kind of cool thing, I think, is that it's kind of hard to tell what altitude they are at in this video. From lunar orbit, kind of a high altitude looks the same as a medium altitude. It looks the same as a low altitude. It's just craters all the way down. But here in just a second, the spacecraft will be all the way down as soon as it zeroes in on this landing site there. It's in a region called the Ocean of Storms. So let's go take a closer look. I'm going to lift us off the surface of the Earth here, and we're going to fly to the moon. Now, it takes most spacecraft at least 3 days to get to the moon's neighborhood. In the interest of time today, we'll be there in a couple of seconds. And I'm also going to show you all of the spacecraft we have exploring the moon right now. Chang'e 5 is the newest arrival, but it is not alone. There are about half a dozen spacecraft in orbit around the moon right now, and China actually has 3 landers. As far as I know, all 3 of them still operating on the surface, so let's get the full fleet of explorers up there. Now, Chang'e 5 has been busy the last few days. It landed just back on Tuesday, on the 1st of December. Started imaging its landing site, sending information back to the Earth pretty quickly. This is a real image of the landing site. And it's actually a pretty big picture. If you run across it online somewhere, go ahead and zoom in on it all the way. Probably looks a little bit better on my screen than yours, thanks to the compression of the video over the internet, but there are a lot of details to be seen here, and the spacecraft got right to work collecting its sample. It had a drill on board that drilled down below the surface of the moon. Getting subsurface samples is pretty useful, and had a little scoop that it used to pick up some of the soil nearby. There's an image of the scoop digging some little holes on the moon, depositing that in the top half of the spacecraft, and then just yesterday, the top half of the spacecraft lifted off from the moon. So it is in orbit around the moon right now. Is working on aligning its orbit with the other orbiter that China sent there to the moon. They'll dock in lunar orbit. That is scheduled for tomorrow. And then the spacecraft comes back to the Earth. And if everything goes as planned, we'll have lunar samples here by probably middle of December. Pretty cool event. And so it's kind of a really quick sample return mission. I mean, just a couple of days on the surface of the moon, 3-4 weeks from start to finish. But sometimes it takes a little bit longer to get the samples you're interested in back to the Earth. And of course, the moon isn't the only other object in the solar system we've tried to sample. So I thought for the rest of today's show, we would we'll take a look at some of those other sample return attempts. So what I have marked here in the solar system are all the other places that we have tried to collect samples, aside from the moon. That one I've been pretty successful. It's most common. So here's some lesser told sample collection stories here. So what do we have? Well, we've got the sun marked there at the center of the solar system. We've got a handful of asteroids. We've got, it's a moon of Mars there, Phobos. I'm actually going to take that off of the list for today. It was targeted by one spacecraft about a decade ago, but something went wrong. It didn't successfully leave the orbit of the Earth, and it's not going to be targeted again until a future mission a few years down the road. So we'll leave that for another show. And then we've got, this orbit up at the top of the screen. That is actually a comet. Now, its name looks like Wild on your screen right now, but comets are named after their discoverers. And this is one of them that was discovered by a Swiss astronomer, Paul Wild. This is comet Wild II. And it was the target of a fascinating spacecraft called Stardust. Stardust's story starts over 20 years ago when it launches from the Earth, and it gets out to the comet a few years later. Comets, of course, famous for growing atmospheres and tails as they approach the sun. So we're seeing a thin atmosphere, a little bit of a tail here around comet Wild II. And I'm going to fly into the Stardust spacecraft itself. Now, where does this atmosphere called a coma come from? Well, as energy from the sun warms up the comet, it causes some of the ices in the comet to sublime, turn from a solid directly into a gas. This process lifts up some of the material from the surface of the comet, so lots of little tiny particles. That's two that have lifted off the surface of the comet and now kind of exist in this thin, tenuous atmosphere. Now, I'll try to get the comet on your screen, but the spacecraft didn't have to get very close because these atmospheres are pretty big. So it just flew through the atmosphere of comet Wild II, and it extended this little sampling device. I'm going to zoom in just a little bit for you. It's kind of like a tennis racket. It's blue, sticking out of the back of the spacecraft here. And that sampling device is filled with a substance called aerogel. Aside from having a cool name, it's got cool nicknames like solid, smoke, frozen, air, all other combinations of those words. But it is a substance that is 99.8% nothing. It's very low density. It was a gel. You have all the liquids extracted. So you have this very delicate material. And that was important because you want to bring these pristine samples back home to the Earth. So when these tiny particles, got me again, when they run into the aerogel gently slows them down and traps them. So then they fold up that sampling device. They store it in the sample capsule, was attached to the back of the spacecraft there. The spacecraft, after flying by comet Wild II, flies by the Earth, drops off that sample return capsule. It lands here on Earth. Scientists are able to open it up, study those samples, and in this case, they learned unique things like some of the atoms and molecules in this comet. I think some of the molecules may have formed a bit closer to the sun in the early days of the solar system, and comets we think form farther out in the solar system. So that tells us that somehow in the early days, material was mixing throughout the infant solar system. So that was kind of one of the big breakthroughs from this mission. Now, in the delay between Stardust collecting its sample, actually flying by the Earth, getting back home took a couple of years, there was another spacecraft collecting another unique sample. This is the Genesis spacecraft, and it was stationed for a short time, not too far from the Earth. There's the Earth with the orbit of the moon in the background there, and Genesis was tasked with sampling the sun, or more specifically, the solar wind. Solar wind is a stream of charged particles. That was close, but that wasn't quite it. Charged particles that stream away from the sun all the time. I like to think of it as kind of the sun's extended atmosphere, but you might hear other people talk about it in different ways. It's really kind of the magnetic sphere of influence from the sun. So these charged particles are streaming out from the sun all the time. They impact objects throughout the solar system. When they get to the Earth here, they can get caught up in our magnetic field. The magnetic field guides these particles down to Earth's atmosphere. When they impact the atmosphere, they cause the aurorae. And the solar wind can have other effects throughout the solar system as well. But when they get into Earth's atmosphere, they've been altered. We can't really study them very well that way. So the goal of Genesis here was to collect a pristine sample of the solar wind and bring it back to the Earth. So it exposed these metal disks to the solar wind. After a time, it closed up the sample return capsule, returned to the Earth. The return plan is really cool, or was really cool. This was, again, about 15 years ago. There's going to enter the atmosphere It would deploy a parachute, and then a helicopter would swoop in, actually grab onto the parachute, and oh, well, yeah, there was a device in the sample return capsule that was installed correctly. The parachutes never opened, so the sample return capsule crashed into the Utah desert. Yeah, looked pretty bad. But despite the damage, scientists were still able to retrieve some of those wafers, those metallic discs that they had in the sample capsule, and actually extract some tiny particles of the solar wind for study. And that again has revealed unique insights into the chemical composition of the outer layers of our star. So a pretty important mission, pretty cool story. Let's see, let's move on to my favorite subject, and hopefully by now one of yours, asteroids. And they've been a frequent target for sample return missions as well. The first was a Japanese mission called the mission was called Hayabusa. I was jumping right ahead to the asteroid itself. The asteroid is named Itokawa, and that's the world you're looking at now. Now, Itokawa is an example of a near-Earth asteroid. And near-Earth asteroids are the ones that come close to the Earth. They pose a high-impact threat to our planet. We don't know of any that are actually going to run into us in the next couple hundred years, but if any are going to hit us, we should know as much as possible. So in a roundabout way, an asteroid sample return mission is a little bit like taking a vaccine. Well, it's been in the news a little bit recently. It's not a perfect analogy, but hear me out. Asteroids could pose a danger to us. So instead of just waiting for a full-size asteroid to crash into the Earth, we go and get a little bit of that asteroid. We introduce that sample of the asteroid to our systems here on Earth. Scientists study it and devise defenses for us that might help us in the future. And of course, these asteroids record the history of the solar system. They tell us how the planets themselves were built. They may have helped deliver the building blocks for life to our planet, may have helped seed our oceans with water in the early days of the solar system. So useful for that reason too. So the Japanese Space Exploration Agency sent the Hayabusa mission here to Itokawa to study it. It hung out at the asteroid for a couple of months, mapped its surface, picked out a place to collect a sample. The spacecraft descends to the surface of the asteroid. On the first attempt, it remained in contact with Itokawa for about 30 minutes. And now the plan was to fire a small projectile, a little bullet, essentially, that would disturb the material on the surface of the asteroid and allow it to be captured by the sampling device on the spacecraft. Well, on that first attempt, the projectile didn't fire, as expected. They made a second attempt. The projectile still didn't fire. And they actually lost contact with the spacecraft for a period of time. Mission Control worked diligently to restore contact with the spacecraft. They were successful, and they went ahead with the rest of the plan for the mission. The spacecraft leaves the asteroid, swings by the Earth, drops off its sample container. Scientists open it up, and they find that even though things didn't go as expected, they had still picked up some tiny particles. I almost heard you that time, from the surface of Itokawa. And they have helped reveal some details of the composition of this asteroid. And the mission itself revealed some interesting details, like the kind of two parts of the asteroid you can see here. There's a longer section you're seeing on the left and a smaller one on the right. They actually have different densities. So they were probably separate asteroids originally, and they joined up later on in their history. So lots of interesting facts from visiting this asteroid. But with this mission only being partially successful, it left some unanswered questions. So a successor was planned, the Hayabusa II mission. Hayabusa II, instead of just spending a couple of months at its target, explored the asteroid Ryugu for about a year and a half. And it's out in space right now. It's left the asteroid. But while it was at Ryugu, well, they really pulled out all of the stops. If you're going to collect a sample from another object, what do you need to do? Well, first thing you have to do is map the surface of this other world. Here are real images of Ryugu, captured by the Hayabusa II mission. And if you remember some of my previous shows where I covered the OSIRIS-REx mission, since I've talked about it so much, I won't mention too much today. But both these missions, OSIRIS-REx at Bennu and Hayabusa 2 here at Ryugu, were pretty surprised by how rocky their asteroids were. They're essentially rubble piles in space. But that's okay. Hayabusa 2 was well equipped to explore here. It released a number of landers. 3 landers in total descended to the surface of the asteroid. Those are images from one of the Minerva landers. Then it was Hayabusa 2's turn. To collect a sample, you've got to touch the asteroid. So similar to the original Hayabusa mission, Hayabusa 2 descends all the way to the surface of the asteroid. And this time, to make sure they knew what was going on, there were cameras on board. So we get to watch it too. You see the asteroid in the background there, the spacecraft up in the top corner. And that's a sampling device, a sampling horn extending from the bottom of the spacecraft there. So they're going to make contact with Ryugu. Again, a projectile, a little metal bullet, is fired into the asteroid. As we can see, it churns up some material, so a sample should have been collected. But Hayabusa 2 wasn't done just yet. I mentioned before the interest in subsurface samples. How do you get under the surface of an asteroid? Well, for Hayabusa 2, the answer was an explosively propelled projectile. So a device called the Small Carry-On Impactor was shot into the asteroid, and then Hayabusa 2 again selects a sampling site close to the crater that resulted from that impact, and again they fire a little metal impactor and turns up more material. Looks like another successful sampling attempt. Now, in the previous shows about OSIRIS-REx, I told you how mission scientists working on that mission had planned to measure how much they picked up. No such plan existed for Hayabusa 2, but we don't have to wait very long to learn how successful the sample collection attempts were. This should be more or less the current location of the spacecraft. And let's see, that object there, well, that's the Earth. The spacecraft is making its return flyby of the Earth as we speak. We're just a few hours from it releasing its sample capsule. If I've converted the time zones correctly, which I didn't do correctly yesterday, I think we're just still about 5 or 6 hours away from capsule release. It'll happen overnight for us tonight here, and then when it actually lands on the Earth around noon tomorrow for us here on the East Coast, Australia will be in its path. So mission scientists are in Australia right now. If you want to follow along with the mission, I recommend their Twitter feed. It's both updates on the mission and interesting Australian wildlife that they're spotting while they wait for the capsule to return. It's pretty fun. And of course, the Hayabusa 2 mission website has details for you as well. You can follow along. We'll have some live YouTube broadcasts as the capsule prepares to separate and enter the atmosphere as well. And hopefully, if everything goes well, they'll open up that capsule after it safely returns to the Earth, and they'll find they got more than just a few tiny particles. Handy water break for me. All right. Now, the Hayabusa 2 mission doesn't necessarily end tomorrow. Yes, they're dropping off their sample from Ryugu, but another kind of cool thing about sample return missions is if they're designed in this way, you've got a spacecraft that's dropped off its sample, and hopefully it's still perfectly healthy. The same thing happened with the Stardust mission. The Stardust spacecraft dropped off its sample, and they kept on flying, still in orbit around the sun, and ended up revisiting another comet that had been visited by a mission called Deep Impact, which is another story. And there's a plan for Hayabusa 2 to continue its mission as well. It'll fly by the Earth this weekend. It'll drop off its sample from Ryugu. And then the plan is to do a couple more flybys of the Earth, adjust its orbit, visit another asteroid, one called 2001 CC21. That'll be a quick flyby. And then rendezvous with another asteroid named 1998 KY26. Now, 1998 KY26 is, at least in my opinion, pretty interesting target. It's pretty small, only about 30 meters in diameter. That's 33 yards. There were boulders on Ryugu that are larger than this entire asteroid. But the way things work, there are many more small asteroids in the solar system than there are large asteroids in the solar system. So Earth is much more likely to be impacted by something like KY26 here than it is to be impacted by something like Bennu or something like Ryugu. These small ones also more likely to burn up in the atmosphere, but we don't know for sure unless we visit them and see what they're like up close. So hopefully Hayabusa 2 makes it to this goal. The plan is to not get there for about 11 years, so a lot has to go right. But hopefully we know more about this little kind of asteroid in the coming decades, I suppose. If you've watched any previous shows, you know that I enjoy these asteroid missions, and they've got many uses, and they teach us a lot about our place in the solar system. So there you go, whirlwind tour of sample return missions here in the solar system. Whether you're getting huge collections of rocks from the moon, large collections picked up from asteroids, or just a few grams of tiny particles, I think they are pretty interesting ways to explore the solar system. If you aren't able to follow along with Hayabusa 2 this weekend, I will try to bring you some updates. I've got another show coming up in just 2 weeks, so circle your calendar. I believe it'll be December 18th, same time, 3:30 Eastern Time. Friday afternoon. We'll be approaching the winter solstice, so we'll talk about that, as well as that event involving Saturn and Jupiter that I mentioned at the top of the show. A great conjunction is occurring on the 21st. With a name like that, I'm going to cover that for you in the next show. So stay tuned. Coming up in 2 weeks. I hate to end on a down note, but I do also want to add a little addendum to my last show 2 weeks ago. I mentioned the Arecibo Observatory, and it plays a pivotal role in the understanding of asteroids in our solar system, especially those near-Earth asteroids that pose a threat to us here on the Earth. Hayabusa 2 may be visiting 3 asteroids, great, but the Arecibo Observatory helped us understand the size, shape, and orbits of nearly 1,000 asteroids in the solar system. 2 weeks ago, I told you that a couple of cables had broken there at the observatory, and crews had determined it was not safe to try and repair because of the threat of collapse. And unfortunately, back on Monday, that suspended platform did collapse at the observatory. So I guess the decision to not try and repair it at this point was correct. It's really a blow for astronomy in general. Various fields, especially asteroid science, planetary defense was a big part of its role. There's no other telescope in the world that could transmit the radar that Arecibo had. So there are movements. They're trying to gain support for rebuilding something like it, replacing its capabilities. We'll have to bring you updates in the future, but tough news for sure. So just wanted to update last week's show. I want to thank you for tuning in today, and I hope to see you again in a couple of weeks. Until then, stay safe out there.